We are Group 10, and we have designed a novel artificial disc replacement nucleus designed specifically for athletes. I'm Sarah.
I'm Lorenzo.
I'm Sylvia.
And I'm Dan.
So there's an increased need for new artificial disc replacement for athletes participating in high force producing or high contact sports, which frequently cause herniated discs. These patients are often unable to return to their sport because the current artificial disc replacement process won't hold up to these sports. The disc replacement strength is not equal to a healthy spine, and as you can see right here, the strength of the current artificial disc replacements varies between 45% and 65% of the strength of a natural spine, and so that actually increases the risk of injury for the athletes if they were to return to their sport. Right here we have a chart of various forces on the lumbar discs from these different activities that are the high force producing or high contact sports as compared to walking speed. So people's preferred walking speed is about 2.5 times their body weight of force on their lumbar discs, whereas a golf swing is more 6,100 newtons to 7,500 newtons. Football linemen are looking at about 8,500 newtons of force on their lumbar discs, and then competitive weightlifters over 17,000 newtons, which is an enormous quantity of strength to try to dissipate with an artificial disc replacement.
So for our approach, we wanted to really focus on certain design criteria such as our lumbar mobility, shock absorption, and wear resistance. We decided to focus on polyurethane as our material for our nucleus, as it has greater energy dissipation and absorption, and less dynamic stiffness and much greater wear resistance as compared to other popular materials such as titanium and polyethylene. For our design, as you can see here in the image, we have it attached to the upper and lower disc and our polyurethane material in the center, and it would be held down through mechanical properties.
So as Sylvia said, with the polyurethane, there's going to be an increased energy dissipation and shock absorption, which is an extreme benefit. Additionally, there's going to be a higher resistance to abrasion with polyurethane, which will lead to fewer wear particles. Additionally, our ultimate goal is to get athletes back onto their field or whatever, so they will have greater mobility in their lumbar with this polyurethane device that we're creating. However, some of the costs, it's currently considered an experimental operation. So because of this, it'll be more expensive. Even with Medicaid, it'll cost a patient $34,355, and it'll go all the way up to $50,000, some even estimated $69,000. Surgeons will also require special training. There are 3 different regions where they have to focus and learn how to operate. Additionally, patients are going to be more reluctant to try this product because it's experimental. However, if we have long-term clinical studies, we can develop the product, and a lot of these costs will be declined because it won't no longer be considered an experimental operation.
So looking at the current state of the art in disc replacement, we have the Active-L disc by Asculap and the ProDisc L by Dupuy. Both of these discs use polyethylene for their core, and the problem there is it does not have the greater force attenuation properties that polyurethane does for the athletic performance that we would need, because athletes are going to face much greater compressive forces on their spine than their typical day-to-day person. So that's why we've chosen polyurethane in this case. Also, the Active-L artificial disc does not have a ball and socket joint like the ProDisc L for that 6 degrees of freedom rotation to allow for the spine to move in torsion like an athlete would have to do in many competitive situations. And so our device has the highest shock attenuation properties, the mobility of the 6 degrees of freedom that's natural to the spine, and also the greatest wear resistance, as polyurethane is naturally more wear resistant than polyethylene. Does anyone have any questions?